So, what if we are trying to solve for an exponent, which whenever we want to solve for an exponent, that is the exact purpose of logarithms. So, what we're going to do is isolate the exponent, or the exponential part, and then what we can do is take the logarithm of both sides is one way to do it. We could also switch to logarithmic form, so I'll kind of show you the two ways to go about that and which you like best. And then we solve for the variable, and what we have to do is check our solutions. So it's always good practice to check our solutions, but for these we absolutely need to, because we can only plug in certain things into a logarithm. So we want to be careful of extraneous solutions. So be sure to check answers at the end, because some might not actually work. So let's solve these equations. I'll kind of show you these two different ways. So we have 7 to the x minus 1 equals 4. So what I'm going to do is add 1 to both sides. So I'm going to have 7 to the x equals 5. So now I have the exponential part isolated. And now there's two ways to go about it. So I'll show you these two ways, and I'll kind of tell you about how I switch between the two and when I prefer one over the other, but both ways work. So one way, which is typically what I do for questions like this, is I just change it to logarithmic form, because we have base, exponent, value. So I have a base of 7, exponent of x, and a value of 5. So what I do is we're solving for our exponent, so we would have x equals, and then we would have a logarithm base 7 of 5. And then with our change of base formula, we just found out how to solve that. So what I'm going to do is put into the calculator log of 5 over log of 7. So we can get a numerical value out. Log of 5 over log of 7. So 0.8271-ish. 71. And checking my answer, I'm going to go back to how it's printed on the paper. So I'm going to have 7 raised to a power of, I'm just going to grab that last answer, and then minus 1, and that's equal to 4. So that works out great. So that's the way of just changing to logarithmic form, which only works sometimes with these. It's not going to work for our last example, so I'll bring that up when we get to that one. But when it does work, I find it a bit simpler knowing my change of base formula. But what if we don't want to use change of base formula, even though it still ends up being the change of base formula? What the steps say up above is take the logarithm of both sides. And really, you can, it's kind of same idea. You can either use base 10, you can either use base e. It just has to be the same for both sides. So if I use my natural log, I would go natural log of 7 to the x equals natural log of 5. Then what I would do is use that exponent property. So I have this natural log of 7 raised to the power of x, and what I can do is bring that x out front. So that's the same as x times natural log of 7 equals natural log of 5. And now I can solve for x by dividing both sides by natural log of 7. So we end up with natural log of 5 over natural log of 7, which is exactly what I plugged into the calculator for the change of base formula. So it just has it separated, so you don't use the change of base formula. And again, I could have done all of this with base 10, and it would have been the same exact answer. So this method always works for solving exponential equations. If we follow the correct steps, that should take care of it. So either way, let's go to this 10 to the x squared equals 8. Yeah, I did check my answer. Okay, I'm just gonna make a note to myself because I had that moment, I've got to make sure we check, which it did. Okay. 10 to the x squared equals 8. So, again, two ways we could... Actually, this is base 10. This is real nice to just switch right to logarithmic form. So, we have base 10, we have an exponent of x squared, and we have a value of 8. So what I'm going to do is switch this so we're solving for the exponent, so x squared equals logarithm base 10, so just log of 8. And then what we're going to do is take the square root of both sides, which whenever we do that, we're going to end up with plus or minus. So I'm going to have plus or minus the square root of log base 10 of 8. And with that, we're going to go to the calculator. So I want the square root log of 8, which is a 0.9503. And with that, while I'm here, I'm going to try this out. So 10 to an exponent of that answer squared. And that's a positive 8. And if it was negative, because that's squared, it's just going to give the same answer. So that works out. X equals 0.9503 plus or minus. So we can have a positive or negative. And it checked out when we plugged it into the calculator. All right. Last scenario here. So with this one, we have two exponential parts. So if we need to move things around, but really we would like to have one on each side. Let me move this more to the center here. So 2 to the x plus 3 equals 5 to the 2x plus 1. Now this one, changing to logarithmic form, isn't going to help us. It will just get messy if we do that. It's possible, but let's go the route of taking the logarithm of both sides. So I'm going to take the natural log of the 2 to the x plus 3, and I'm going to take the natural log of 5 to the 2x plus 1. And with that, the exponents come out front, and just notice that with these expressions in the exponent, they get grouped in parentheses and come out front. So in parentheses, I would have x plus 3, and then that's multiplying with natural log of 2. And then equals, and same thing, in parentheses, 2x plus 1 would come out front. So 2x plus 1 times natural log of 5. And now we want to solve for x. So to solve for x, what we want to do is simplify both sides of the equation first and get everything with x on one side, everything else on the other. So we're just following our rules of solving for x with a linear function. I don't know if I really want to say linear here with these values, but yeah, I guess it would still be good. So what I'm going to do is distribute that natural log of 2 in to the x plus 3. So I'm going to have x times natural log of 2 plus 3 times natural log of 2. And then on the right-hand side, I'm going to do the same thing with the natural log of 5 by distributing that in. So we're going to have 2 times natural log of 5 times x plus 1 times natural log of 5. All right. So there's my equal sign. I'm going to move things so I have everything with x on one side, everything else on the other. So I'm going to subtract 2 times natural log of 5 from both sides. So over on this left-hand side, I'm going to, actually let me write that out. I'm going to subtract 2 natural log of 5 times x from both sides. And then what I'll do is that'll get everything with x on the left-hand side. Then I'm also going to just go ahead and do this all in one. I'm going to subtract 3 natural log of 2 from both sides. So I'm getting that away from that left-hand side of the equation. So on the right-hand side of the equation, we're going to have natural log of 2 times x minus 2 times natural log of 5 times x, and then equals, and then over here we have that natural log of 5 minus 3 times natural log of 2. All right, so we have everything with x on one side, everything else on the other. So on the left-hand side, I have these two terms with x. We can't combine them. We could, but it would just be a messy decimal. So instead what I want to do is I want to factor out x. So I'm going to factor out x. So I have x times natural log 2 minus 2 times natural log of 5 equals natural log of 5 minus 3 times natural log of 2. And then what we can do is divide away from x. So what I'm going to do is divide this left-hand side by that whole expression that I factored x out from. So natural log 2 minus 2 natural log 5 divided by natural log 2 minus 2 natural log 5. And then it's just a matter of typing it into the calculator. So I'm going to go to my calculator and do, let's see, fraction, natural log 5 minus 3 natural log 2 over natural log 2 minus 2 natural log 5. So we're getting a 0.1861. 0.1861, and let's see if that's even right. So we're going to plug it in to the original equation. So 2 with an exponent of 0.1861, and then plus 3. So I need parentheses in that exponent to group it together. All right, I'm getting 9.1015. And if I have 5 raised to a power of 2 times 0.1861 and then plus 1, 9.1017. Those are very, very close. Again, that 0.1861 is rounded, so it's a little off, but if those should be balancing the equation, those are nice and close. So with these, you can either just switch to logarithm form and solve that way, or take the logarithm of both sides and get to the answer in that way.